Hi, imagine this scenario. You wake up, 8:55 a.m., your alarm goes off, you roll out of bed, walk over to your desk. This is now your office since we're all working from home during the pandemic. You open up your laptop and you see there's a meeting scheduled at 9 a.m. with your CTO. Of course, that meeting wasn't in existence yesterday in the evening, but that's how your CTO rolls. So you quickly fix yourself up, make yourself look presentable, brush your teeth, and dial into the Zoom meeting. Now your CTO is going a mile per second, babbling about something, and eventually your CTO gets to the point. I read an article that said all successful companies need to be multi-cloud. Get us multi-cloud by the end of the half. And then your CTO hangs up. Now you're staring at that prompt in Zoom that says your meeting has ended, and you're pretty angry. Half of you angry because you haven't had your coffee yet, and the other half of you angry because you had this giant project dropped in your lap. Multi-cloud and cloud migration is just not easy. And the reason it's not easy is because of this concept called vendor lock-in. As you use a cloud provider, you start using more and more services that they provide. So imagine you start to use S3 for storage, you start to use Kinesis for streaming, etc. And these services make your life and software easy to build, but the more you use these services, the more you get stuck with that vendor. You get locked in with that vendor because they are more or less proprietary to that vendor. So now you have this Herculean task to break through vendor lock-in so that you could go multi-cloud. But then you wonder, is there a way to say, screw the harder way, we're doing this the smarter way? Hi, I'm Larry Finn, the author of Cloud Sidecar, and I'm going to talk to you about how Cloud Sidecar can help you take your existing or even new software and make it work on multiple clouds or to switch clouds. Now, beyond that silly story about your CTO saying you have to go multi-cloud, there are a variety of reasons to actually go multi-cloud. In this infographic from the information, it shows the rising costs of cloud bills, specifically AWS bills, for some notable companies. Being able to go multi-cloud or to switch clouds is a way that you could actually optimize your bills and try to keep your bills lower, maybe pit some clouds against each other. We've all been there where your app or your website is just running slow. So you go to your cloud provider status page and it says everything is A-OK. But then you realize half the internet isn't working, so everything is not A-OK. Your cloud provider is clearly on fire. Now, if you were multi-cloud, you could easily fail over to another cloud and have no interruptions. I'm going to be honest here, it's probably best first step to be redundant within multiple data centers or regions within a single cloud before redundancy to multiple clouds, but being multi-cloud is an exceptional level of redundancy. Some clouds just provide better services than others. So one cloud might be great at storage, another cloud might be great at big data, and a third cloud might be great at machine learning. Wouldn't it be amazing if you could pick and choose the features of each cloud, mix them together, and make your product the best it possibly can be? And finally, cloud providers are not just single companies that provide cloud services. They're actually these giant corporations that do a lot of things. So Amazon is a huge retailer. Google is the largest ad tech company. And Microsoft, apparently they put trackers in vaccines. Now, you might be working with companies that might not feel comfortable to be working with these cloud providers. So imagine you are a B2B company, you're hosted on Google Cloud, you do something with data, and a prospective company is in ad tech and doesn't want to use you because you are on Google Cloud. Actually going multi-cloud or switching clouds is a two-piece problem. There's the infrastructure problem and the software problem. I'm not going to really go into the infrastructure problem. That's not my strong point, and it's mostly a solved problem. You can use infrastructure as code like Terraform and be able to build your infrastructure on a different cloud, or use Kubernetes and just pick up all your infrastructure and just move it to a new cloud. But what I'm going to talk about is how do you handle your software? How do you make that multi-cloud or enable it to switch clouds? Imagine you have a piece of software that works on AWS and you want it to work on GCP. AWS is Amazon and GCP is Google. So it's a simple Python application. You use the Boto library, which is the Python Amazon library, and you're connecting to S3 for storage and SQS for queues. Now, how do you make this work on GCP? Well, you would have to build a storage abstraction library or some sort of library layer that sits on top of both Boto library and the Google Cloud Storage library. And your code would interact with this storage abstraction library, and underneath the hood, it would switch between Boto to go to Amazon or Google Cloud Storage to go to GCS, which is the Google storage. Now, your abstraction would have to be a single interface that supports functionality in both clouds. And you have to do a similar thing for Q abstraction library. You would have to wrap around the Boto library and wrap around the Google Cloud PubSub library. Now, imagine you have that CTO, that great CTO that decided that your company should be polyglot so that any engineer can choose any language they want, because what's the harm in that? So now your system has some Python, some Golang, some Scala, some Node.js, some Java, maybe some esoteric languages like, Clojure, Erlang, Haskell, whatever. Not knocking any of these languages, but that's a lot of languages to support. Now you're also using a lot of cloud services. So you use S3 for storage, SQS for queues, Kinesis for streaming data, DynamoDB for document store, and Redshift for big data. So you have these N languages and these M services. So now you have to build those wrappers of N times N. Like each language has to have wrappers for each of these services. And that's a lot of libraries and code to write. Imagine also, you're a pretty big company, you've invested in microservices. So in this example, there's 1,500 plus microservices. So now not only do you have to change all those codes in different languages for different services, you have to do it in 1,500 plus applications, which might be using cloud services in vastly different ways, might be accessing and using different libraries. You might not be a very dry company. So this could be a deploy nightmare and could be really complicated to roll out. So this is where Cloud Sidecar can help you, can help solve these problems. Now imagine you have that Python application that uses the Boto library to talk to AWS. What Cloud Sidecar does is it gets deployed next to your application in the sidecar design pattern. A sidecar design pattern just means an application that sits next to your application and helps your application. And this is a well-known design pattern. You have it in Zookeeper, Console, any service mesh like Linkerd. So you have Cloud Sidecar sitting next to your application. Your application talks to Cloud Sidecar instead of the cloud itself. So you tell it to talk to Cloud Sidecar. It thinks it's talking to Amazon in this example. Cloud Sidecar translates all the requests, the API requests, to Google Cloud, gets the responses from Google Cloud, and translates it back to Amazon. So your Python application doesn't change at all, thinks it's still talking to Amazon, but it indeed is talking to Google Cloud. And because this is transforming API requests, Cloud Sidecar can support any language, as long as it has like a cloud library. And also, in theory, it could support any cloud because it's just translating between API requests. Getting a bit into the nitty-gritty of how the software actually works, imagine you have your application with the cloud library, whatever it happens to be, and you could deploy Cloud Sidecar on this machine. Let's say you're using like an EC2 machine. You deploy it next to it, and you configure your application to connect to localhost via the cloud library. Or if you're using Kubernetes, there's a sidecar design pattern built into Kubernetes and you deploy it that way. Now Cloud Sidecar is running and it exposes an HTTP router to handle these API requests and a configuration to drive which different types of APIs are supported and which ports they're on. So we can have S3 or an S3 interface exposed on a specific port that your application connects on. And when your application connects on that port, it gets routed to the correct handler. So for example, it'll get routed to the S3 handler on port 3450. Now, once your request goes to the S3 handler, it will convert the request from AWS, and it might just send it directly to S3 AWS and just be passed through. Or it might interpret the request, convert it to Google Cloud Storage, get the response back from Google Cloud Storage, and send everything back, making it look like it came from S3. So your application thinks, for all intents and purposes, it's talking to S3. Or in this example, SQS or Kinesis. Cloud Sidecar is written in Golang, and there's several good reasons for this. This is a sidecar which runs next to your application, so you want a very minimal footprint, very small memory and CPU footprint. And Golang is great for this. It's not like JVM, which will eat all the memory on your machine. Go is also a very simple language, which is great for an open source project, where people can easily dive into it, contribute code, modify code, etc. And there's a lot of open source libraries that it can use and take advantage of. And finally, Go is a very performant language. It has a very nice concurrency system, and it also has a lot of low-level constructs. Now, it might not be as performant as languages like Rust or C++, but But because of the simplicity of the language, Go wins out over those languages for this project. I'm going to show you a demo application that kind of wrap this around into a little more of a concrete example. So imagine you run a image conversion website. We've all been there where you have a PNG file and for some reason you need a JPG file. So you Google PNG to JPG conversion, find a website, click upload your PNG, and you get a link to the JPG and you're happy. So you're running this website and it's actually doing great. It's a great website, makes good money on ads, but AWS is charging you more and more and more for their S3 services. And you look into it, and Google Cloud Storage is way cheaper. So you wonder, how can I pick up my system and move it to Google Cloud? So let's look at the architecture you have. You have this Scala application using the Play framework, which is a front-end framework, and users interact with it. They click upload, and it will upload a PNG to S3. And then it will put a message on SQS with that S3 URL. Now, on the other end, you have a Python worker that's listening to SQS for these messages, converts the image from PNG to JPG using some open source library, and then uploads the result into S3, which then the UI displays. It's actually a great architecture because you can scale up the workers as much as you want, and you could scale up the front end as much as you want. S3 and SQS can handle a lot of load. So I've actually pre-recorded the demo, which this whole thing is pre-recorded, but demo I'm going to actually show you is this image uploading system using Cloud Sidecar to handle multiple clouds. This is the UI. I'm going to dive into the Scala code. Here it's just a simple controller where I inject two modules I created, an S3 module and an SQS module. Now the S3 module uses the standard AWS Java library, and it just tells it to connect to localhost on a certain port. And now when I interact with S3, I interact with it the way I always do in Java. Similarly here, I am using the SQS library and just connecting to localhost on a different port. Now in the worker, I'm using Boto3, similar SQS, S3, and I'm just passing it an endpoint URL, whatever port I want to use. I'm going to start up the worker, just running one worker because what I scale. So I'm going to show you my S3 bucket, show you there's nothing there right now. I'm going to show you my GCS bucket, nothing there right now. There's nothing up my sleeves. I'm not even wearing sleeves, but that's not important. So now I'm going to upload an image to my application. Everything's running, and Cloud Sidecar is running pointing to AWS. So what happens is my Play application is going to upload to S3, worker picks off a message from SQS and uploads to S3, and then I'm going to actually see this in my UI as the resultant image. Now if we look at the Amazon bucket, we see the JPG and the PNG, the source and destination, and on Google Cloud we see nothing. So now I'm going to restart Cloud Sidecar with a different configuration. This one will point to GCS. Typically, you don't even need to restart Cloud Sidecar. It dynamically loads configs, but it's easier for the demo. As you'll note, I didn't actually restart my worker or my Scala app. So now I'm going to upload a new image. It's going to actually go to GCS. A message is going to go to PubSub. The worker is going to read it off PubSub, convert it, and upload to GCS. And then we will see the image here. New image. And as you can see, the source and destination image are now in GCS, and they're not in S3. Really, really cool stuff. Now that you've seen the demo, what are all the features of Cloud Sidecar and how can you actually use this at your company or your site? Right now we have two editions, the Community Edition and the Enterprise Edition. Community is completely open source. The Enterprise is open core, but this might all just merge into open source. It's just things we're playing with. So as I mentioned before, both of them support any language, any programming language that you're using, and they both support AWS to GCP conversion as the main thing. I've been adding GCP to AWS conversion a little bit by a little bit, but no other clouds yet. For file storage, they both support S3 to GCS, and for file storage, they also both support GCS to S3. For queues, we support SQS to PubSub, and for streaming data, we support Kinesis to PubSub. And I'll go into what these queues and streaming data solutions actually are like. Cloud Sidecar also supports customizable plugins. So imagine if we didn't support SQS, you could write a plugin to support SQS and just drop it in, and Cloud Sidecar will pick it up. You don't even need to recompile Cloud Sidecar. We also support customizable middleware. So if you want to write some sort of logging middleware, metrics, encryption, etc., you could write that really easy and drop it in and configure it. Now in the enterprise versions, we support a few more functionalities. We support key value, which is DynamoDB to data store or Bigtable. We support big data, so we support Redshift to BigQuery, the SQL conversions. And also for big data, we support customizable stored procedure style plugins. So basically, if you've used a lot of databases, SQL doesn't always convert to the most optimized SQL in different dialects. Here you could write your own plugins that look like stored procedures, call them from queries, and then have Cloud Sidecar call that plugin, which generates a different query based on your end destination. So you can make it as optimized as you want. We also support metrics integration, StatsD, and Datadog because, well, that's the big dog. For S3 to GCS, we support list 1 and list 2, the two types of listing, ACL, head, get, put, multi-part upload, delete, multi-delete, and copy. Now, I've kind of glossed over something, but these different services in different clouds, while they're super similar, there are small caveats of how they're different. And one important one for S3 to GCS is S3 supports something called multi-part upload, which GCS does not support. So what's multi-part upload? Imagine you have this really large file, let's say 10 gigabyte file, and you want to upload it. Now, uploading a 10 gigabyte file is going to take a long time, and then you might get interrupted, and it's a pain in the bum. So with S3, what you could do is say, I want to create a big file upload at this destination URL. And S3 will say, cool, you just need to upload all the parts to this URL and tell me when you're done. So what you do on your client side is you split up this 10 gigabyte file into 1 gigabyte chunks, and then you could upload them in parallel or however. And once they're all done, you tell S3, I'm done. It merges those chunks together and puts it at the destination. GCS does not have multi-part upload, but it has something called combine, which will combine some amount of elements already uploaded to GCS. So underneath the hood, we use that to mimic multi-part upload. Now there's other caveats with the S3 API that I've discovered along with GCS. I could talk about it at length. I won't bore you, but if you're ever interested, just hit me up and we could chat about it. For GCS to S3, which is in beta, feature we just recently added, we support list, ACL, get, put, resumable upload, combine, delete, and copy. Similar to the S3 GCS incompatibilities, resumable upload and combine are not natively supported in S3, so we mimic them using some of the existing functionality in S3. Great, so going on to queues and streams, I want to explain the different queue offerings of the clouds and then what we offer on top of them. So on the far left, you have SQS, the simple queue, which is the simplest one. Basically, you create a queue, you post messages to it, and then workers can listen to this queue, and workers will alternate who actually gets the message. So it's great for worker pools. On the other end of the spectrum is Kinesis, where you'll create topics, drop messages into that topic, and they just flow through. And whoever's consuming these messages, they keep track of the offset of the message they last read, and then they just keep reading messages after that offset. Kinesis is a lot more similar to Kafka if you're used to Kafka. So SQS and Kinesis are both AWS. Somewhere in the middle is PubSub, which is the GCP offering, Google Cloud offering. And this is sort of like RabbitMQ if you've ever used it. You post messages to the PubSub topic, and you can actually create an arbitrary amount of queues attached to the topic, which will start accumulating messages once they're published to the topic. And then the queue kind of works like SQS, where you could have workers attached to them, and they'll retrieve messages in some alternating manner. They don't have any offsets or whatever. So for message queue, we support SQS to PubSub, and the functionality we support: list, create, purge, delete, send batch, receive, delete message, and delete message batch. For Kinesis to PubSub, we support get records, get shard iterator, describe, publish, create stream, and delete stream. Now for NoSQL, which is mostly a document store, key value store, we support DynamoDB to data store. Just so you know, I'm not even sure if it's still called data store. They might call it Firestore because data store took over Firebase. All this crazy Google Cloud stuff. But the functionality we support are get item, query, scan, put item, update item, and delete item. Now, interesting caveats here between DynamoDB and data store. DynamoDB has the concept of query and scan, which both search for items or filter for items, but use different methods for it. Data store does not have that. So these two function calls end up being the equivalent in data store of one function call. And also, DynamoDB has like a pretty complicated JSON nested filtering and updating system. Data store does not have such a system. It's a simpler language. So we try to convert it as best as possible. We're constantly improving this functionality of Cloud Sidecar. So for big data, this is kind of an outlier where all the other systems I spoke about have a simple pretty much REST API. Maybe there's XML if it's S3. That's how old S3 actually is. But for big data on AWS, we use Redshift, which is actually somewhat related to Postgres and has a Postgres interface. So for Cloud Sidecar, we actually expose a Postgres interface for big data. So your application is not even a cloud library you use. You might be using however you connect to a database. So it might be JDBC or whatever you use to connect to a Postgres database. You point it to connect to Cloud Sidecar instead of Redshift. Cloud Sidecar, of course, is using this config to realize if you actually want to connect to AWS as a destination or Google Cloud BigQuery as a destination. If it's Redshift, it just kind of proxies the queries through to Redshift and proxies the response back to you. If it's BigQuery, it will consume the SQL, interpret it, and convert it to a BigQuery SQL, and then respond with parse the response and return it as if it was a Postgres or Redshift response. Now, if you actually use our special stored procedure plugins, there's special commands in your SQL to call those stored procedure plugins. And if we see that, we'll call your code and pass to it the destination is trying to actually trigger. And then your code, you could say, hey, if this is called with certain parameters, Redshift is my destination, create a SQL query like this. But if BigQuery is my destination, create a SQL query like that. And this is all dynamic, and really you could optimize it as much as you want. So for our general SQL conversion, in big data, we support insert, select, delete, unload, which is basically to export data, copy, which is basically to import data, rename table, create table, and drop table. Great, so I've told you like some arbitrary example demo of how this could work in the real world and all our functionalities, but who's actually using this? Cloud Sidecar is mostly a side project of mine, but my day job has been at a company called ActionIQ or AIQ, and we're what's known as a CDP, a customer data platform. So maybe you could interpret it from a picture. What a customer data platform does is it works with large companies, sucks up all this large company's data from various data sources, internalizes it, makes it usable, makes it so that this data can actually be built into user audiences, and then those audiences can be exported into external systems like email, advertisements, etc. So let me give you a concrete example. ActionIQ has Michael Kors as a customer, and Michael Kors has data about online orders, online clicks, online returns, in-store purchases, in-store returns, etc. There might be stored in like various data stores. ActionIQ sucks all that data in, and then we have a really nice user interface that lets marketers working at Michael Kors to build segments or audiences of customers based on some criteria. So they might want to find out who paid over $3,000 in shoes last year, but has not bought shoes this year. So they could quickly put that into our system, drag and drop, see a count in really quick time, realize that this is like a nice audience size to target, probably could get us some good sales. And then they could send those customers a coupon via email and then a cool dance video via TikTok, because everyone likes dance videos, or TikTok. I don't know. I don't use TikTok. So ActionIQ has typically been on Amazon. But we started getting approaching customers that said they do not want to be on Amazon for multiple reasons. And they would prefer to be on Google Cloud. So we went under taking a project to go multi-cloud with Google Cloud as our second cloud provider. Of course, we did the infrastructure, which I'm not going to get into, but we were able to leverage my project Cloud Sidecar to make our software work on both Google Cloud and AWS with very little code change. Since we are a big data company, we use a lot of the AWS services to really make it so that we can move data very simply. So being able to just deploy Cloud Sidecar with our application meant that we were able to save a lot of time making code changes, etc. And we actually were able to release multi-cloud before our deadline, which is shocking to me because I've never released before deadline and made our customer very happy. We've been using Cloud Sidecar in production for many months to years now. Of course, we found bugs and we fixed them, and big help in us going multi-cloud and making that customer successful. Great, so I've told you everything about Cloud Sidecar. You heard my spiel. Please try it out. Go to cloudsidecar.com for more information. We have a link to our GitHub, which is at github.com/cloudsidecar. Try it, download it, play around with it. You could contribute to it, our open source project, you could create issues, all that good stuff. Also, if you're interested in the enterprise offering, if you're like a big company, feel free to reach out to me through the website or email me at larry@cloudsidecar.com. I'm also always free to talk about multi-cloud or anything really. So hit me up. I'm always around. Got nothing else going on during the pandemic. If you want to see the image uploader, that code is real. You could go to github.com/LawrenceFinn, Cloud Sidecar image demo. And if you want to just follow me on Twitter, I'm at Lawrence Finn. I have 3 followers. One is my mom and one is my cat. So I don't know, maybe there's another follower out there. And I'm also on LinkedIn if you haven't used that.